Alright, welcome back. We are going to look at some final tests on this here escape with this here fuel pump that you may or may not know that I went ahead and replaced. Now in this video we're going to be talking about checking relay contacts, and it's not using an ohm meter, which is not really the best way to check contacts. And with this method you can check relay contacts, switches, pressure switches, doesn't matter. The only thing that does matter is you got to know the current is going through this switch, and we're going to verify that too. So we're going to show that because I want to know the condition of this here relay contact, and then we're going to take and we're going to put a brand new relay in there and we're going to look at the difference. I don't know what it's going to be, so it'll be news for you and for me too. Now the other thing we're going to talk about is Kirchhoff's current law. That's cough, just like you cough. And also we're going to talk a little bit about the amp clamp, some of the ways to use it, some of the things you see on it maybe and you don't quite understand it. So we're going to take this step by step and let's get started and see where we're going. Alright, before we go out to the car, let's talk about Kirchhoff's current law. Okay, sometimes you'll see that as KCL. And here it is just in a nutshell. Let's say that I had multiple currents, and now let's say they're coming into a node or a splice. Let's say this if it's on a car. Now let's say I had 2 amps here, maybe 5 amps here, maybe 3 amps here. Well, what it's saying is that the sum of all these currents entering this node, we total these up, and that current has to be equal to 10 amps. Total these up, that's what you're going to get out here, 10 amps. And that's it in a nutshell. That's it.
Okay.
So now let's go to the next thing here. Now we've already been over this diagram. If you haven't seen this here video on this, I'll put a link in the video and you can follow it if you like. Now we have this fuse right here, which is hot all the time. It's fuse F1.6, 20 amp fuse. We got a current, it's coming down, it's going through the relay contact, it's coming down. Now, notice we have a current path coming out here. This is going down through the inertia switch, also going down to the fuel pump. Okay? So, we have the current path here, and we also have this current path, here's like our node, our splice point. We have current coming down to here. So if we take these two currents, add them together, that's going to be equal to this current that's being supplied to this node or splice. Now, this here, you see this current's coming down, it's coming to the PCM. Now this here is going to be an input because a B plus is coming down, going in this direction. That's going to be an input going to the PCM. Now this here input is used for diagnostic purposes as far as the PCM is concerned to look at the integrity of this here circuit. For example, it knows that when the switch is off, this relay contact is open. Therefore, the PCM will be looking for a ground at this point. The ground is being supplied from here, going through the motor, coming up, going through the inertial switch, and then it's coming around to here. So it knows that it should be 0 volts. And if it sees B plus voltage on there, then it knows that that wire, or this here circuit, is shorted to the B plus line. And then you'll get a code. Or on the other hand, when you turn the switch and it's running, the engine is running, we know the relay's contact is closed, and now it's going to be putting a B plus up to this here input. And at this point, it knows everything is good. But what if there wasn't a B plus here? Then again, it knows there's an issue. So again, you can get a code. Now look here, this current that's branching off, that's going to the input, is going to be a very, very small amount of amperage. We're talking down into the microamps. This here point that's up here on the PCM for the input has a very high input impedance. So the current that's coming down this is going to be in the midst of an amp. So this is negligible. So we can measure our current here, We can measure it here. Now, of course, we will get this little tiny bit here, but it's negligible, so we don't care. My point is that you want to see what is on the fuel pumps circuit, because you may be feeding, say, injectors, ignition coils, or some other loads, and those are going to be substantial load. So in the case like that, let's say this line was feeding injectors. Well, obviously, you want to be putting your clamp on this line, anywhere down here. So the best place probably would be right here at the inertia switch, which is located on the passenger side inside the cab, right behind a little access panel. So you could measure it right there. But in our case, since we have very little current right here, I'm going to be looking to measure it right up here. Okay? So let's get ready. Let's go for our next step now. This fuse is F1.6. Let's see if we can locate it. Here's a fuse, F1.6, located over in the battery junction box. So let's go over there and see if we can find it. So let's get this here cover off. This is where a fuse should be located at. And 20 amp, there it is, right there. Okay. So now I'm going to pull this fuse out. Now I have my test light. I've got it hooked up to DC negative on the battery. Okay. This is not necessary, but I'm just illustrating my next thing about amp clamps. Now if you remember, this fuse was hot all the time. So I want to see which side is hot. And I can see it's this side over on the right. Okay? And of course if I go over here,
gotcha.
there's nothing. It's hot over here on the right hand side. This direction. Okay? Now I'm going to take this here, and I'm going to put that 20 amp fuse that we pulled out, and I'm going to stick it.
What is that thing?
This is a little component here which allows you to get an amp clamp around, and also has a test lead point coming out of here if you want to check your voltage. Okay.
Gotcha.
And now what we're going to do is we're going to take this and stick right down into the fuse holder.
Gotcha.
So we'll stick him right down in there. Okay?
Doesn't matter which way, it just goes.
Does not matter which way.
Okay.
Okay? All right, now take a look at the amp clamp. I'm leading up to why I wanted to know which side. This way you know which way to put a clamp on. You get it right the first time. If you look inside the jaw, most of the amp clamps, you'll see an arrow. Okay?
Yeah.
And if you look up there, you'll see a plus.
Yep.
What this is telling us is it's set up for conventional current flow, meaning that the current is flowing from positive to negative. Okay? Now, since this arrow is on the inside, you have to kind of look a little bit, turn it. So what I've done is I took the arrows and I drew them on the outside of the jaws so I could see them right off the bat. Okay?
Yeah.
So imagine my current, my positive is over on this side, positive to negative. So it's going to be going just like that. Okay? Positive here, negative. Positive to negative.
Gotcha.
So you see,
yeah,
I'm flowing in that direction. Now when I do that, I should get a positive amplitude, positive magnitude number. Okay? Now, another thing, some amp clamps you'll see, you'll have these little, looks like minus signs on there. There's one, and there's one up here. Okay?
Yep.
And if you look on the other side, you see the same thing.
Yep, that's right.
What do you reckon those are for?
Dunno.
Those are alignment marks.
Ah.
To get the most accurate reading when you're measuring current, the wire, when it goes in, you can put it around in here anywhere. But if you put the wire, line it up with this here, horizontal, and get it up vertical, which is probably maybe about like that, which is pretty much about in the center of the clamp, you will get the most accurate reading of the current that you're measuring. Okay? All right. Now let's go back over here. Let's take a look. Now you remember our positive remember hot all the time was over here on the right, on
Yes.
this wire, okay?
Yeah.
Now that means my current, conventional current, is flowing in this direction, right? It's coming up, it's going around, and then it's going back down, coming through the fuse, right? One more time, on the right-hand side, over here.
Yeah.
Current's coming up this direction.
So
We're
it's
talking
this
about
way.
conventional current, coming in this direction, and then going through the fuse and going back down.
Gotcha.
Now, all we have to do now is we see our arrow, we know our current is coming in this direction on this wire, we hook it on, and we're set.
Gotcha.
And if you want the most accurate reading,
Get it in the middle.
put your wire right in the center, put it on the alignment marks, and you'll have the most accurate reading for your amps. Okay? All right. So now, let's go ahead, let's crank up the engine. All right, let's turn on the amp clamp. As you can see, it's already set for DC. One of the first things I do is I open, close the jaws a few times. What that does is demagnetize the jaws if you have any kind of residual magnetism in the jaws there. All right. Now, most amp clamp manufacturers recommend, not a requirement, but what they recommend is that get next close to the wire in kind of a similar orientation of how you're going to be putting the clamp on, and you want to zero it. So it's zeroed. Notice that our arrow, I have it in that direction, so I'm just going to clamp around it. Now I'm going to try to get my alignment marks on there pretty close. Something about like that. Is that what you're shooting for?
6, 6, 6.
Just a little higher.
Yep. So that should be the most accurate measurement we can get. All right. So I'm gonna call it Let's call it 6.7.
Yeah.
Yep. Okay. So anybody wants to know? Brand new fuel pump, brand new fuel filter. 6.7 amps is what you should be getting. Next thing we want to do is we want to check the relay contact. We want to see what kind of condition that is. So, to get access to the pins, of course, we need to pull out the relay. Okay. Now, since the relay is pushed all the way down, we're going to use an adapter here so we can bring the relay up. So, with the relay and with the relay adapter, let's put them in, and let's put this one in. And we're done there. All right, let's crank up the engine. Now we know we got like 6.7 amps of current going down through the fuel pump. That 6.7 amps is going through this relay contact. So what we're going to do is we're going to measure the voltage drop across that relay contact. From the industry, we've checked a whole bunch of them, and we found pretty much if anything is under 50 millivolts, and we've talked about currents going up to maybe 15, 20 amps for motors. You can also do this for AC circuits. We're looking at the relay contact is good. So let's check this one here. Let's see what kind of voltage we get on this. Remember, our relay contacts 3087. That's
Right.
the terminal numbers. If you don't know anything about that, go back to the other video. It's all in there. So let's go to terminals on there and let's see what we get for our voltage drop. Alright, so here's our two terminals right here, and I'm looking up there and we got 23 millivolts.
Is that good?
That's very good. For a relay that is 17 years old, and I doubt very seriously it's ever been replaced, this is a very good contact and therefore a good relay. Okay?
Yep.
Well, let's get a brand new relay. Let's put it in there. Let's do another test. Let's just see how that one looks. And remember, the closer this voltage is to 0, the better your relay contact is, okay?
Oh, okay.
All right. Okay, I shut the engine off, I pulled the Motorcraft relay out, and I put a brand new relay in here. Now this is Wells VE relays. Those will be high quality. Well, let's see how good it is. Let's see how it compares to a relay that's 17 years old. So I'm going to cross the relay contacts 30 and 87. And what do we see? 31 millivolts.
That don't make sense.
Well, what doesn't make sense?
Well, I thought the lower to 0, the better.
That is exactly right.
But this one's new.
This is new. So which one is the better relay?
The old one.
The old one is better.
Don't make sense.
Yeah. So there you go. So the old relay contact is better after 17 years. This is a new relay. I mean, there's nothing wrong with it. I mean, far as you know, we're under 50 millivolts is what I use as a kind of a standard here. But if you're looking and comparing relay contacts, this is the way you can do it. You're doing it dynamically under actual load conditions. It's a lot better doing it this way than putting an ohm meter on there, but that you're pushing maybe like 20 milliamps of current through there. That's not simulating a load. You've got burnt contacts and things of that, oxidation. You close the contacts and you still probably gonna get good reading through an ohm meter. This here is pushing, this is stressing this contact. This is what you want to see. So right now, like I said, we got 30 millivolts, so of course the other one is better. So we're gonna put the other one back in there.
Cool.
Okay. When you're doing these tests, like when you want to check a relay contact like I was just showing, or if you want to check a switch or pressure switch or any kind of switch, it doesn't matter. Anything's got contacts, you can do the same method. However, you've got to make sure that you have current going through that switch or relay contact or whatever you're checking. That's why we checked our current first. We wanted to make sure that we had a current going through this relay contact. Okay, so just make sure you got current coming through your load. Alright, so I've got the PicoScope hooked up here, and I'm going to be taking the waveform of the fuel pump just for my database here. So I'm going to be using a 20 amp clamp. I'm going to set it for the 20 amp mode. Now if you notice and look inside the jaw, you see that plus sign and you see that arrow just like we did before. Again, conventional current flow. So I have my arrows on the outside of my clamp so I can right off the bat tell that it's going to be going this way, just like what we did before.
Okay.
Okay. Now, again, you can open and close the jaws to demagnetize them. Get next to the wire, just like you're going to put it on, and zero it. Now, put it on, and now we're set. Okay? So now we're going to be starting up the car. Alright guys, right now we're looking at the waveform. Now while we're here, let's just maybe go over some of the stuff that some of you guys might want to know about. This might be new to PicoScope or maybe scopes in general. Now right up here I have a time base set for 2 milliseconds per division, which will give me a total screen time, if you look in the lower right corner, 20 milliseconds. Now I think this here fuel pump has 8 commutator bars. It might be 10, I am not sure. But I'm just going to look at it as 8. I still have the old fuel pump, so I could turn it down and take a look. Biggest thing I want to do is just get a capture here. Now, what I do is when I do captures, I always want to get a look at my sample rate. So I'm going to right mouse click, I'm going to go to view properties. So if you look over here, the sample interval is taking a sample point and measuring across the screen in time horizontally. Every 400 billionths of a second is taking a sample. Well, that's probably a little bit overkill. So what I can do for the time that I have set on the screen, I can take my sample rate and I can turn it down. If you're looking like at ignition waveforms, you want to set that for 1 microsecond, because the whole entire duration of that, of where the coil gets charged, the time that it's on, the dwell period, you know, the firing time, the burn line, you're only looking at 3 milliseconds. So you really want to sample every 1 microsecond. So I pretty much set my stuff, say for, you know, for 1 microsecond. So what I do is I'm going to turn down the sample rate, and if you look, you can see the sample interval is now at 1 microsecond. So now that's what I have. Now we can take and we'll put a trigger on here, so I'll put it on repeat, There's my trigger point. So if I move off, you see it disappears. I bring it back up in. So this will stabilize the waveform. Okay, so now let's take a look and we'll freeze it. And let me go ahead, we'll turn this here engine off. Okay, let's get back to our waveform. Alright, so you can see what we have. And we have this here waveform. Okay, so we can see, let's take a look here at our peak current. We can see that we're running at 7.297. And we were going down to the bottom. I guess this would be, let's just call it right there. So we were going down to 5.764 amps. Now if we wanted to know pretty much what is in the middle there, we could bring up the calculator, of course, and we can say 7.297 plus 5.764. We take that divided by 2. So you can see we're running about 6.5 amps, which is pretty much what our amp clamp was telling us earlier. Okay. Now let's take a look at our time. So we're going to find, what we're going to do is we want to measure the speed of this pump. So let me see, we got 1, 2, 3, 4. I'm just looking for something that looks pretty common. Let me put him out of the way. Let's just kind of zero in on some of this stuff. Let's see. Let's get a little more. Just looking for one that's going to repeat itself. Let's look at this low one here. Right there. 2, 3, 4, 5, 6, 7, 8. And that looks like the one that's going to repeat. So I'm going to kind of put him about the same. Yep, about the same. In fact, what we could do, be a little bit more accurate, let's put him right down in here, in that peak, in that valley. There we go. And if we want to zoom in, we can kind of zero on it a little bit more. Yep, that looks good. Let's go back to our previous screen. Now if you come down here and look down in the lower right corner, it tells us this pump is running at 7,642 RPM. This is with a brand new fuel pump and a brand new fuel filter. Okay. Now if you don't have this here feature in the scope like PicoScope where it can calculate your RPMs directly, you can do that by typing in 60,000. If I can type. Now we want to know RPM, so it's 60,000 because there's 60,000 milliseconds in 1 minute. And we're going to divide that by the time between these two cursors. In other words, how much time is it from this cursor to this cursor, which represents 1 revolution because we framed out 8 commutator bars, assuming this is a pump that has 8 commutator segments on it. We have a time of 7.851. So we divide that by 7.851 milliseconds. And you see that we have a pump speed here of RPM of 7642. And if you look down here, you can see that it's very, very close. The only reason it's off in that last little digit there on the 0.6 minus 0.3 is just because I had my cursor not in the exact spot there. Oh, one other thing that might be helpful here. A lot of people don't know about it, but these cursors here, what you can do is you can come to this little padlock right there, click on it, and what that'll do is that will lock these cursors down. So you can see that this first cursor looks like it's pretty much the same as that other one. If I go to that one, yep, that signature, yep, that looks the same, that looks the same. So that's just another feature that's in PicoScope. Alright guys, that's going to wrap this video up. Now you know how to check a relay contact, or any switch for that matter, or at least the right way. I've seen guys on YouTube and they'll pull the relay out and then they got all these jumper leads hooked up and they got the coil hooked up to the battery. Then they got more leads hooked up to their voltmeter, and then they're measuring the ohms and resistance and putting the lead off and on.
Good
Like
days.
I said, when you're measuring resistance, it ain't gonna tell you nothing. Even with oxidation, corrosion, and pittedness, you can still get a reading right through that ohm meter. When you only got about, say, 20 milliamps of current flowing through a relay contact, and you're trying to simulate something, you know, some of these, let's say a contact in the industry, you got one that's got 100 amps or more for a motor. And so you want to sit there and check a relay contact with an ohm meter. Best way to do it dynamically, stress the contact, put the actual current going through it, and then measure the voltage drop across that contact. And hopefully the other little tidbits there with the amp clamp, how to use it properly, maybe some of those things can be helpful too. Well, you guys take care, and we'll see you in the next one. Hope you learned something.